Good evening, my YouTube viewers. It's Crystal here, and I'm just here this evening because I wanted to make a code review on a program that I wrote a few days ago, but I've been really busy the last few days, which is why I haven't had a chance to do the code review on it. And so basically what I've done is I've made my own data set using numpy. And so this is just an example of if you don't want to have to go around looking for a data set, you can create your own data set with numpy if you know what kind of a data set it is that you want. So this is a really simple data set, but you can make it as big as you need to make it. And I'm probably going to start doing that in the future rather than scrambling around looking for data sets. So what we're going to do is the first thing we're going to do is we're going to import our libraries. So we're going to import numpy as np, and numpy is your numerical computation library that performs linear algebra, and it also creates numpy arrays. And it's the numpy arrays that we're going to be using to create our own data sets. And then we're going to import pandas as PD. Pandas is written on top of numpy, but it's your data frame making facility. And strictly speaking, you don't strictly need a data frame to make predictions on this, but I decided that I wanted to have a data frame anyway. So that's what I'm going to do. And we're going to import matplotlib.pyplot as PLT. That's your graphics library, because we're going to be plotting some graphs of the data points as they appear in memory. And then we're also going to import Seaborn as SNS, and Seaborn is written on top of matplotlib, and it's just a little bit more sophisticated data set, and we're going to be using that to create data sets as well. So after we've imported our libraries, then what we're going to do is we're going to create our data set. So height equals np.round brackets np.random.normal brackets 1.75 is like the mean height, and then 0.2 is going to be the variance, and it's going to be 10,000 people. It's going to be a float rounded to the 2. And then weight equals np.round brackets np.random.normal, and 60.32 is going to be the mean weight, and it's going to have a variance of 15, and it's going to be for 10,000 people, and it's going to be rounded to the 2nd digit after 0. And then we're going to go ahead and create our data frame. So np city equals np.column stack height brackets height comma weight brackets. And then you can see np.city. So we've got 2 columns. We've got the one column with the height and then another column with the weight. And then we're going to create some statistics as well. So city mean equals np.mean np.mean brackets np city square brackets colon comma 0 square brackets, and that's the mean of the height. And city med equals np.median brackets np city square brackets colon comma 1 square brackets, that's the median of the weight. And then we're going to print the mean of the height, which is 1.749, and median of the weight, which is 60.14, which is very close to what we had identified previously. So now we're going to take this, what really is the numpy array, and we're going to convert it to a data frame using pandas. So city equals pd.data frame brackets np city comma columns equals height comma columns equals bracket height comma weight square brackets. City BMI equals brackets city weight over city height to the power of 2. And then, so what we've done is we've created an extra column called BMI. So you can take their height and their weight and you can calculate their BMI. And that's what I've done. I've calculated the BMI for 10,000 people. Now what we're going to do is we're going to plot how this appears in memory. And so you're always supposed to plot your data onto a graph so you can see what it looks like. And this is what it looks like in memory. So plt.figure brackets fig size equals brackets 12,8 brackets plt.scatter brackets city.iloc square brackets colon comma 0 square brackets comma city.iloc square brackets colon comma 1 square brackets comma c equals city.iloc square brackets colon comma 2 square brackets comma alpha equals 0.4 brackets. And so we put that code and you can see where it is in memory, and it's just, I think it looks really nice personally. It's always nice to see how things appear in memory. So now what we're going to do is we're going to analyze the BMI, and we're going to use C-form to create a plot of the BMI. And so sns.dispplot brackets city BMI brackets. So this is what city BMI looks like, and you can see over here that it does have a few outliers. So you can take the BMI. Some people have a high BMI. There's a few outliers, but most of the BMI is around between 10 and 30 or 40. But if you have a BMI of under, I think 18, you're underweight. And then if you have a BMI of like over 28, you're overweight. So it's important to know what your BMI is. And that's why I wanted to calculate the BMI, and see where we stand with that. So now what we're going to do is we're going to create a box plot. PMI.figure brackets fig size equals brackets 20,8 brackets sns.boxplot brackets x equals city height comma y equals city BMI comma palette equals blues brackets semicolon plt.show brackets. So you can see all of the box plots. These are called box and whisker and box plots, or box and whisker plots, and you can see that it shows where your quartiles are, but you can see that the greater the height, the lower the BMI is, which I think is interesting. So as someone gets taller, his BMI is going to decrease, because you can see right here people who are not very tall have higher BMIs than the people who are tall. So that's interesting. And now what we're going to do is we're going to define our x and our y variables. Your x is independent and your y is dependent. So your y equals city BMI and your x equals city height comma weight. And we're going to split the data set up into training and validation sets. So train len equals int brackets len brackets city brackets times 0.9 brackets. X train equals x square brackets comma train len square brackets. Y train equals y square brackets colon train len square brackets. X val equals x square brackets train len to colon square brackets. Y val equals y square brackets train len colon square brackets. And now what we're going to do is we're going to select our model, and we're going to use linear regression for this particular program. So from sklearn linear model, import linear regression. Model equals linear regression brackets dot fit x train y train print brackets model.score brackets x train comma y train, and you have almost a 94% accuracy. And then so what we do here is we going to print some coefficients. So print brackets coefficients comma model coef, and that's -24 and 0.34. And the next line is print brackets intercept model intercept, and that's 42.74. And now it's print number of features seen during fit, and that's model comma model.n features in, and that was 2. It only had 2 features. And then the next line is print feature names comma model.feature names in, and the feature names are height and weight. So those are your feature names. So now what we're going to do is we're going to predict on the model. ypred equals model.predict brackets xval brackets print comma model.score brackets xval comma yval brackets brackets, and you got a 94% accuracy, which was very close to the accuracy when we trained and fitted the data into the model. And now what we're going to do is we're going to check our error. So MSE equals np.square brackets np.subtract brackets yval comma ypred brackets brackets dot mean brackets, and that's your MSE. That prints your MSE, and you get an MSE of 3.23. And now we're going to get our RMSE, which I like to work with RMSE. That's root mean squared error equals np dot square root brackets MSE. We're going to print our RMSE, and it's 1.796519. So that's your error. So you can see what the error is. Now what we're going to do is we're going to plot a graph and see what the data looks like on the graph. So fig comma ax equals plt dot subplot brackets ax dot scatter brackets yval comma ypred comma edge colors equals brackets 0 comma 0 comma 0 brackets ax dot plot brackets square brackets y dot min brackets comma y dot max brackets comma square brackets y dot min brackets comma y dot max brackets comma, and k dash dash comma lw equals 4. And the next line is ax dot set x label is measured, ax dot set y label is predicted, plt is shown. So you can see that on the dashed line is your prediction, and the blue dots are the observed values. And so you can see that the blue dots are very close to the dashed line, which is why it had a high degree of accuracy. But what we can do I just was hoping there was something we could do to improve the accuracy, but I can't see anything really simple right off the bat that we can do to improve the accuracy, other than you mess around with linear regression. So we just do okay. So fit, intercept, mobilize, copy, and jobs positive. So it doesn't really say much. It says attributes, and it doesn't say a whole lot, does it? It says fit, intercept, normalize. I'm going to try fit, intercept equals normalize equals true. Let's try normalize equals true and see if we can let's just make sure I spelled normalize correctly. Let's give it a try, see if we can improve our score, because it was close to 94. Nope, it didn't. Actually made it worse. Let's just see what it says. Well, it you got a warning, but it said normalize was deprecated in version 1.0 and will be removed in 1.2. It says if you wish to scale the data, use pipeline with standard scaler, but it did actually very slightly improve the prediction. So even though it's deprecated, we'll go ahead and use it because I was just trying to find a way to improve the prediction. But it's deprecated. So yeah, that's not very nice. See what else. Fit intercept. Let's try fit intercept equals false and see what happens. Fit intercept. Let's try that. No, that made it worse, a lot worse. So the fit intercept just made it a lot worse. We can't use normalize because that's deprecated. It says positive. Let's try positive equals true. See what happens. Let's try that. Nope. So everything we do is made our accuracy worse. So we can't do anything to improve the accuracy. We've done everything we could to improve the accuracy, and actually it's worse. So that's all we can do with this program. We've done everything we could do to try to improve the accuracy. So I'm going to go ahead and conclude this video because we've done the code review and we tried to improve the accuracy, but we couldn't. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my video, and I look forward to making more videos for you in the future.